Hey guys, today we are going to review what we've learned about proportions here in chapter 6. So we're going to start by solving some basic proportions, and we'll do that with the cross products property. So here we have 2 times x, that's 2x. And here we have 4 times x plus 4, so we need to distribute. So we get 4x plus 16, and we can subtract 4x. So we get negative 2x equals 16, and divide by negative 2, so we get x equals negative 8. So our next proportion, we have 3 times x, so 3x equals 6 times 35. Okay, so we have 6 times 35 is 210. And divide by 3, and we get x equals 70. Okay, our next one, we're going to distribute again, just like we did here. So we have 4 times x and 4 times 2, so that's 4x plus 8. And then 10 times 8 is 80. So we will subtract 8. 4x equals 72, and divide by 4, so we have 72 divided by 4, and that is 18, so x is 18. And our last one here, we're going to distribute again, so we have 2 times 2x and 2 times negative 8. So 2 times 2x is 4x, 2 times negative 8 is negative 16, and then 6 times 4 is 24. So let's add 16, and 24 plus 16 is 40, so we get 4x equals 40, and divide by 4, x is 10. Next, we will use some proportionality theorems. So here is an angle bisector in a triangle. So that means that 8 is to x as 16 is to 8. Okay, so our cross products are 16x and 64, and divide by 16. So 64 divided by 16 is 4. Okay, now we have 2 parallel segments here in a triangle, and that divides the sides proportionally. So x is to 20 as 15 is to 30. So we get 30x. And then 20 times 15 is 300. And we divide by 30. And we get x equals 10. Here we have 3 parallel lines and 2 transversals. So these are the 2 transversals. And when we have 2 transversals on 3 parallel lines, the transversals are cut proportionally, so 4 is to 7, as 5 is to x. So we get 4x equals 35. And we divide by 4. 35 divided by 4, we could actually just leave the answer as x equals 35 fourths. Or we can divide 35 divided by 4 is 8.75. So if you gave 35 fourths as an answer or 8.75, that would work just as well. Okay, so our next one, we've got parallel segments in a triangle as well. So these sides are cut proportionally. So 2 is to 6 as x is to 8. So we have 6x equals 16. And 16 divided by 6 is 2.6 repeating, and that's the same as 2/3, so it's 2 and 2/3. So you could give your answer as 2 and 2/3, or 16/6 will simplify. Both are divisible by 2, 8 times, and 3. So 8/3 would be a good solution as well. Okay, so here we have another angle bisector. So x is to 6, as x plus 8 is to 8. So we have 8x, and then we have to distribute 6 times x, and then 6 times 8. 6 times 8 is 48. So we can subtract 6x. We get 2x equals 48, and divide by 2, so x is 24. Okay, another set of parallel segments within a triangle. 24 is to x, as 20 is to 7. 20x, and then 24 times 7 is 168. And divided by 20. So 168 divided by 20 is 8.4. And our last one in this section, we've got 12 is to 16, as 14 is to 2x plus 10. Okay, so our cross products, we'll have to distribute 12 times 2x and 12 times 10, so that's 24x plus 120. And then 16 times 14 is 224. So we'll subtract 120. So we get 24x equals 224 minus 120 is 104, and divide by 24, and we get 4.3 repeating, and 0.3 repeating is 1/3, so it's 4 and 1/3. Okay, so now we are going to find some missing lengths in triangles. So we have a proportion given to us here. zy is to yx, as zv is to vw. Find the length of segment zy. So zy we do not know. So zy is to yx, which is 6, as zv, 12, is to vw, 8. So our cross products are 8 times zy, and then 6 times 12 is 72. And divide by 8, and we'll get zy equals 9. Okay, BC is to FG. So BC is 8. FG is 12. As CD, which is 6, is to GH, which we don't know. So we're going to find the length of segment GH. Okay, so we have 8 times GH equals 6 times 12, which is 72, which we actually just did. So we're actually dealing with the same numbers here. Divide by 8, and we get segment GH has a length of 9. Okay, this time we aren't given the proportion like we were here. We just have to find our own proportion. Find the length of segment AB. So 2 is to AB, as 3 is to 9. Should have parallel markers on here. So these are going to be parallel so that these are proportional. So we get 3 times AB equals 18. Divide by 3 and we'll find that AB is 6. Okay, so here's 3 parallel lines with 2 transversals. 4 is to AB as 6 is to 8. So we get 6 times the length of segment AB equals 4 times 8, which is 32. Okay, and then we divide by 6 and get the length of AB equals 32 divided by 6 is 5.3 repeating, so that's 5 1/3. So next we have a pair of similar triangles. Triangle QRS is similar to triangle XYZ. Okay, so that order is important because it tells us the corresponding points, Q and X, are congruent angles. R and Y are congruent angles. S and Z are congruent angles. It also tells us corresponding sides, QR and XY, RS and YZ, and then QS and XZ are our pairs of corresponding sides. So we want to find the value of X, and X is right here, so I'll use that for sure. X plus 3 is 2, and that's XZ, and XZ goes with QS, which is 18. Okay, then from there I can choose either 10 is to 16 or 6.25 is to 10. So I'll choose 10 is to 16 just to deal with whole numbers. Okay, now notice I started with the small triangle on top here and then the larger triangle on bottom, and then I did that again, smaller over larger. It doesn't matter which goes on top and which goes on bottom, but we have to be consistent. If I do smaller on top here, I have to do smaller on top here. If I did larger on top here, I would have had to do larger on top here. So our cross products, 16 times x and 16 times 3, so we're distributing 16x plus 16 times 3 is 48. And then 18 times 10 is the other cross product, that's 180. So I'll subtract 48. So we get 16x equals, so I've got 180 minus 48 is 132. And then divide by 16. So I get x equals 132 divided by 16 is 8.25. Or I could have written 8 1/4. Okay, next we have a pair of similar figures here. Find the lengths of AB and XY. So AB is to 5 and then I went smaller over larger, so I need to do that again, and the only place I have another set of corresponding sides is 3 is to 5. Now this one we could probably just look at and know the answer is going to be 3. 3 is to 5 as 3 is to 5, but let's do our cross products anyways. 5 times AB equals 15 divided by 5. AB is 3. Okay, and the length of segment XY. So XY is to 5 as 5 is to 3. Okay, so this time we have 3 times XY equals 25, and we will divide by 3 and find the length of XY. 25 divided by 3 is 8.3 repeating, and 0.3 repeating is 1/3, so it's 8 1/3. Okay, so here's a pair of similar figures. Find the perimeter of each figure. So the perimeter of ABCDE is going to be pretty easy. I just have to add up the side lengths. So for the perimeter of ABCDE, I have 7 plus 12 plus 6 plus 8 plus 5. Okay, so I'll just throw that all in my calculator. 7 plus 12 plus 6 plus 8 plus 5 is 38. Okay, so there's the perimeter of ABCDE. So here the perimeter is 38. Okay, now I can write a single proportion to help me find the perimeter of FGHIJ. Okay, so the perimeter of this figure is 38. Okay, so 38 is to the smaller perimeter, and I'll just call that X. So perimeter is to perimeter as 5 is to 3. Okay, so I can just match a pair of corresponding sides. So perimeter is to perimeter as 5 is to 3. So I have 5x equals 3 times 38. 114. And divide by 5. And that is 22.8. So that is the perimeter of FGHIJ. Okay, so there's the perimeters of our two figures. So P equals 22.8. So now we have ABCD similar to EFGH. So these are similar, and we're going to find the scale factor of ABCD to EFGH. Now that means ABCD has to have a number that goes on top. Okay, so I need some corresponding sides from these two figures. So how about if I try using DC? So DC, that's the last two letters, that goes with GH, and I do have numbers on both of those sides, so I can use those. I don't want to use an X or Y. I need two actual numbers to find the scale factor. So I've got 25 over 18.75. Okay? Now, a decimal shouldn't be in a fraction, so for our scale factor, we need that simplified. So I'll do 25 over 18.75 and see what I get. I get 1.3 repeating, which is 1 1/3, but I can change that to a fraction with this fraction to decimal button. So I'll hit second and then fraction to decimal, and it will convert it to 4/3. Okay, so the scale factor of ABCD to EFGH is 4/3. Now if EFGH was first, I would have had to flip this. So whichever one goes first gets its number on top. Now find the value of X. Okay, so here's X. It's on side GF. So GF, that's the middle two letters. That goes with BC. So I've got BC and GF going together. So I've got 56.25 is to X as, and notice I used the larger figure over the smaller figure. And that's how the scale factor is listed, larger over smaller. So I can use the scale factor 4/3. Now if I had done X over 56.25, I would have smaller over larger, so I would have to have this as 3/4. So our cross products are 4X and 3 times 56.25 is 168.75. And I need to divide by 4, and that is 42.1875. 42.1875, that is the value of X. Now for Y. Y is here on FE, so that's the first two letters. That goes with AB, so it's 37.5 is to Y. As 4 is to 3. Notice again I have the larger over the smaller, so I go with larger over smaller. So I have 4y equals 3 times 37.5 is 112.5, and divide by 4, 28.125. That's my value of y. Find the value of z. This one's going to be nice and easy. Z is an angle right here. It's on angle H. Angle H corresponds with angle D. These two angles are congruent. I don't need a proportion here. These have the same measure, so Z is 100. Find the perimeter of ABCD. So I just need to add the four sides of ABCD. 25 plus 50 plus 37.5 plus 56.25. Okay, so I add those together. And I get 168.75 for my perimeter. Okay, then for EFGH, I have 18.75 plus 37.5 plus Y, which is 28.125, plus X, which is 42.1875. Okay, so I can add those four numbers together. So I've got 18.75 plus 37.5 plus 28.125 plus 42.1875, and I get a perimeter of 126.5625. In our last section, tell whether the triangles are similar, and if they are, what theorem tells us so. So if these triangles are similar, the only thing I know about is angles. So they each have a right angle. So there's one pair of congruent angles. And they share this angle right here. So I can say that angle is congruent to itself. So I would say, yes, these are similar by angle-angle similarity. Okay, if these are going to be similar, all I know about is sides. So it's going to be side, side, side if they're similar. So the three options are angle-angle similarity, side, side, side similarity, and side, angle, side similarity. So this one would have to be side, side, side if they are going to be similar. But in order to be sure, we need to check the ratios of sides. So we have 12:8, as 15:9, as 18:10. Now, if those all simplify the same, then I'll say, yes, these two triangles are similar. So we have 12:8, which is 3/2. 15:9, 5/3. Those aren't the same. 18:10, 9/5. Now, if these were going to be similar, these would all have to have simplified the same, but they do not. So I'm going to say no, these are not similar. If these all simplified the same, I would say yes by side, side, side similarity. But they did not simplify the same, so the answer is no. Okay, here I've got a pair of congruent angles. I might have side, angle, side, and it kind of looks like if I do 8/16 and 6/12, they'll probably simplify the same. 8/16 is 1/2, 6/12 is 1/2. So the sides are proportional and the included angles are congruent, yes, by side, angle, side similarity. This one looks like it could be angle-angle similarity. I've got vertical angles. Those are both going to be 36, so those are congruent. And let's do 180 minus 36 minus 91 to get this angle. And that gives me 53 degrees. And that's not the 89 I was looking for. I've got an 89 over here, but not over here. So these cannot be similar.